Welcome to lecture part 2. So we are working on a 135 degree hat channel sheet metal layout. So the first step is to identify the actual points that we have to bend in order, so we can't unbend. So whatever bend we place into the source material is permanent and we can't unbend it, so we need to make our first bend for the upper tier, either or, followed by the outward sides 3 and 4. Next, we have to identify that the bend is actually not 135 degrees, but if it was a straight line, that would imply 180 degrees, so the final bend is 135 degrees subtracted from 180, so the actual implemented bend is 45 degrees. So the complementary and supplementary angles, unless otherwise specified, are also consistently 45 degrees throughout the entire structure. Then we have to isolate the flats from the bend allowance structures, but then the working finish length, including the projection of the setback across the horizontal, and in this case the diagonal planes, is the difference between the finish length, the mold length line, minus the setback value, so that will yield the flat. So to be a little more specific here, we have to take the flat plus bend allowance flat plus bend allowance flat plus bend allowance flat, bend allowance, and flat. And so when we add up these summations, this summation actually, we will have the unbent length. So just to move a little faster here, we can first identify the coefficient of bend, K value, with reference to the neutral axis of the bend. So we're actually dealing with a 45 degree set of bends, so that is a 0.4142 K constant. Then we know the mold length line minus the setback is equal to the flat, so again we'll just identify these in the other direction, starting from left to right. So then our setback equation is the metal thickness plus the bend radius as a quantity summation times the K constant. But first we have to calculate the bend radius, so in this case it's the ratio of 45 degrees over 360 degrees as a ratio times the designated unit of measure. So this is the FAA US system, and those are in increments of inches, or just 1 inch. So we have a bend radius of 0.125 inches unless otherwise specified, since the bends are all 45 degrees from 180 degrees straight line to yield 135 degrees. We have a consistent bend radius of 0.125 inches. So assume we have a metal thickness of 0.040 inches. We would add this to the bend radius of 0.125 inches times the K constant of 0.4142, and this would yield a setback for which we will not round the entire calculation. We'll use it as is, and then the final calculation we can round So now we don't need the K chart anymore. We can go ahead and calculate the flats, flat 1 through 5. So flat 1 is the mold length line minus the setback value. Flat 2 is the diagonal mold length line minus 2 setbacks across consistent 45-degree bends. So we have 2 setbacks with the same value because the bend angles are consistent. And then flat 3 is the mold length line 3 minus 2 setbacks. Flat 4 is consistent to flat 2. And then flat 5 is consistent to flat 1. So we're able to then calculate each flat value in its entirety. So now we can calculate the bend allowance, the actual circumferential metal derivative of a quarter circle or an atypical curve derived out of a circle. So that would be half the metal thickness, 0.5 times metal thickness plus the bend radius. This product sum quantity then multiplied times the constant of 2 pi divided into 4. So if we solve for the bend allowance in steps, we take half the metal thickness. So we get 0.020. Then we add the bend radius, 0.145 inches, and then we multiply that value times the constant of 2 pi, and we divide that value into 4. So again, where do we truncate around? We can use the tolerance plus or minus 1/32 inch, the FAA sheet metal structural tolerance of 1/32 inch is also 0.03125 plus or minus. So again, we could just increase the value. Now if we subtract 0.03125, we would go the other direction, but 1/4 inch is a very clean within tolerance measurement, so we'll choose that one going upward on the positive end. So now we have our bend allowance of 0.25 inches. So the end bend length is flat 1 plus bend allowance 1 plus flat 2 plus bend allowance 2 plus flat 3 plus bend allowance 3 plus flat 4 plus bend allowance 4 plus flat 5. So we'll just put in all these values. So we calculate 16.953256. So if we added the 1/32 inch tolerance and subtracted it as well, we would get this range, and then we could just pick the simplistic nominal value of 16.95, because not only is it simple, but it's also within the tolerance. So it's simple and it's also within the inspection tolerances that will pass. So here's our unbent sheet metal section with constant width. We can zero both sides of it, so when we put it into the sheet metal brake, we have a symmetrical reference, but we must start the bend at the start of bend allowance 3, moving left to right on the curve schedule or the bend schedule. So that is the distance from the right side 0 point flat 5 plus bend allowance 4 plus flat 4 plus bend allowance 3. So we can add these three values up. So we get a value of 5.863314 plus or minus is going to be 5.83 to 5.89, so we'll use 5.85. So we would start our bend from the right side zeroed in. We move the sheet metal section of 16.95 inches in length and place the right side into the sheet metal brake, 0 inch position and 0 degrees angle, and then we would implement a 45 degree angle bend downward. And again, you might have to bend it a little bit more than 45 degrees because the material spring back somewhat to maybe 43 or 42 degrees. So start by placing the first bend, and this section here will turn into the bend allowance, a controlled bend set at 45 degrees. So you go ahead and move it to 45, it might spring back 1 or 2 degrees, and then you might move it up to 46 and 47, and then you have your nice 45 degree bend. And then you repeat the process on the other side as well because it's symmetrical, but you must bend these two first, so first and then second. So the result will be initially a bend that is a longer section of two 45 degree angles, but we'll work on bending the outboards, bend 3 and 4. So again, we will take the F5, flat 5, subtract the setback from this and add this to one setback, which is our one bend allowance, which is bend allowance 4.25 inches. So we get this value here, and we can plus or minus the tolerance 1/32 inch. So we can actually use 3.2 inches as the start bend point from both ends. So we must start the bend, the third bend here, but we're bending upward. And same thing with this other side. So that's the first bend, 245s downward, first and second bends, and then the third bend, the outboard right, upward 45 degrees, and then the outboard left, fourth bend, 45 degrees upward as well. So you'll start out having this shape after bends 1 and 2, and then when you finish bends 3 and 4, you'll have this shape here. So when you're done, you can measure the mold length lines, just making a straight line across here or on a drawing board or drawing table, and you will get approximately 3 inches. And remember, you have a tolerance of 0.03125 inches on both sides, so it's actually a 1/16, 1/32 times 2 tolerance. So if you're a little bit over or a little bit under, as long as you're within 1/32 of an inch plus or minus on both sides, so it's a double of 1/32, 1/32 inches plus or minus times 2 on both sides. You could actually be as much as a 16th off, but only on one side at a time, 1/32 inch. So if you're slightly over or under, that's fine. And now you are done with your 135 degree hat channel sheet metal layout. Thank you for watching this lecture part 2, and have a great day.